Hi, this is Miss Carly, and this is your flip video for 4.2. In this section, we're going to talk about exponential functions, and more specifically, the formula for compound interest. Unfortunately, this formula has to be memorized, and I don't have any cool tricks or ways that you can help you remember, but it's something that you've seen before. I know you saw it in Algebra 2, and you probably have seen it a little bit in Algebra 1. So A is the amount. That's our goal, is to find the amount that's in your account. Usually these are bank account, stock market, some type of way that you invest money and you get money back. P stands for principal. Principal is your starting amount, whatever you deposit. If you go to the bank with $50 and you say, I want to open a checking account, I'm going to put in $50, that would be your principal. 1. That stands for 100 because you're earning interest, which means you're going to keep the money that you have. So you have 100% of your money plus a little bit extra that you earn from interest. So the 1 comes from that your money already. The plus is everything that you're going to earn on top of that. So R is the rate. They're going to give you a percentage. You have to remember to change it to a decimal or your answer is going to be crazy wrong. N is the number of times it's getting compounded in 1 year. So if you want to get a pen or a pencil and write these down, it will be on the right-hand side for this unit. Semi-annually is twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, 52. And daily or continuously means 365. Every single day it's going to get compounded. So it'll tell you in the problem which one of those it is. You just have to remember what number matches all of those words. And then T is the time in years. So it's pretty easy if you have the principal and you have all the information. So just plug it into the calculator and figure out what your amount is. So $100 invested at 2.5% compounded quarterly for 5 years. First thing I'm going to do, take this and change it to a decimal. You do that by dividing by 100 or just move the decimal 2 places to the left. That's the number I need to plug in for R, that 0.025. All right, everything else is pretty easy. If I start with $100, that's my principal. 5 years, that's my time. And quarterly, I mean, that should be pretty easy. You use money every day, and there's 4 quarters in a dollar. So that means you're happening 4 times a year. So this is just a matter of plugging it into the calculator. You can do it all in one step. The only thing that I usually do, if you notice, as your exponent, you have to do n times t. So that would be 4 times 5. I do that separately, and that way I just plug that in. If you don't put that in parentheses, it can be easy to raise it to the n, and then your calculator would automatically leave off the t. All right, so I actually just, whenever I close my parentheses, I'm going to raise it to 20. I just do that n times t separate. So I'm going to pretty much plug it in the calculator exactly the way you would expect for it to look. Right? Principal, 1 plus your rate divided by n, however many times it gets compounded, raised, that was what I got when I did n times t. And that's your amount. Not very much, but if you've ever had a bank account, you actually don't get that much money back. Usually bank accounts, most of them compound it monthly, at least mine does. All right, it's a little bit harder if you're trying to solve for what your principal amount was, or if you're trying to solve for how many years. So that's the next example that we're going to do, is solve for how many years. All right, let's take those same numbers. We have $100, (2.5%), but this time I want to know how long will it take for my investment to double. I don't know how many times. It's still getting compounded quarterly. But I know what double of 100 is. It's 200. When will my amount equal 200? I just don't know how much time it'll take for me to get there. Now you can plug this into y1 and plug this into y2 and graph it and just second trace 5, see where they intersect. They have to be in parentheses together after you hit the caret or you won't get the correct answer. We're going to practice using logarithms to solve whenever there's an exponent that we are solving for. So right away, I'm going to do 200 divided by 100, and that's just going to give me 2. I'm also going to clean up everything that's inside of my parentheses because that's just all numbers. So 1 plus 0.025 divided by 4 is that. I'm going to try to be as specific as possible. I don't really want to round too much or my final answer can be pretty far off. So I'm actually going to put all that back. All right, so this is my base. I'm solving for the variable in my exponent, and this is the answer that I'm supposed to get. This is how you need to change it to a logarithm. Your base is the base of the log. It's the little number that's below it. The argument is the answer that you're supposed to have for your exponential form. And the reason logarithms are easy to use is because the exponent is supposed to be on the other side of the equation. Even though this is a crazy decimal, this can be plugged into the calculator using change of base. Log 2 divided by log of that. Log 2 divided by log of the answer that we got when we found our base. And this part I can round because now I'm getting pretty close to my final answer. So it's money. I'm going to round that to 2 decimal places. So this couldn't be easier. All I have to do is divide by 4. And we get 27.8. Usually years we just round to the nearest 10. So ultimately it takes 27.8 years if you have a 2.5% interest rate that you compound quarterly for your investment to double. All right, so let's go through that one more time. I'm solving for t. The first thing I did was divide 200 by 100 so I could start moving stuff to the left. Then I'm going to find what's actually in the parentheses. I'm going to find what my base is equal to. My base was equal to 1.00625. All right, that's just what I got when I plugged all that into the calculator. All right, because my variable is an exponent, I'm going to change this to a logarithm. That way, all of my numbers are on the same side, and my variable is isolated. So this is my base. That's the little number after the log. It's still called a base. Whatever your answer is for exponential becomes the argument, and then your exponent is on the other side. It's a good idea because the wheel is pretty easy, in my opinion, to use, but it's hard to go backwards from the wheel. So after I put my logarithm down, I like to check. Does my form look like 1.00625 raised to the 4t power equals 2? And that's how you can check to see if you've done it correctly. All right, so once we did, basically undid the wheel, we wrote our logarithm. This whole side gets plugged into the calculator. Log 2 divided by log of that 1.00625. In the calculator, that's what it gave us as our answer. I still have to solve for t. So I just have to divide both sides by 4, and ultimately that's what I will get as my answer.